Hello everyone. In this video we're going to configure inter-VLAN routing via the traditional method, which is also referred to as router on a leg. This method involves connecting each VLAN to a particular interface of the router, responsible for routing the traffic between the various VLANs, as opposed to using VLAN tagging and trunk ports. We're going to create two VLANs, VLAN 10, that is going to have a network of 192.168.10.0/24, and VLAN 20, that will have a network of 192.168.20.0/24. And we will make it so that a host from VLAN 10 will be able to communicate with a host from VLAN 20. So to get started, we will pick a switch 2960, a router 4331, which we're going to place at the top of our topology, and two PCs, one in VLAN 10 and one in VLAN 20. Next up, we're going to install the necessary network media. We will plug a copper straight-through cable from the PC of VLAN 10 to the fast Ethernet 0/1 port of the switch, and we will do the same for the PC of VLAN 20, and we will connect it to the last fast Ethernet port, which is 24. Then we will put a copper straight-through cable between the second port of the switch and the first gigabit Ethernet of the router, and then we will do the same with the 23rd port of the switch and the second gigabit Ethernet interface of the router. Okay, next up we will open up our switch, run enable conft, and we will type VLAN 10, which we're going to name IT. Then we will do interface fast Ethernet 0/1, switch port mode access, and switch port access VLAN 10. We will exit out of there, and we will do exactly the same for fast Ethernet 2, switch port mode access, and switch port access VLAN 10. And that's all we need to do on the switch for VLAN 10. We will need to do the same for VLAN 20. So we will run VLAN 20, we're going to name it sales. We will exit out of there, and then we will go into the last interface, which is 24. Configure it as an access port and associate it with VLAN 20. And we will do exactly the same for the 23rd port. Switch port mode access, and then switch port access VLAN 20. And that should be, that's everything we need to do on the switch. Next, we will move over to our router. Type no, enable conft, and then we will do interface gigabit Ethernet 0/0/0, which is connected to the switch for VLAN 10. And we are going to run IP address 192.168.10.1, and we will give it a subnet mask of /24, so 255.255.255.0. And then we will run a no shut to make sure that the interface is up and running. And we will do exactly the same on the second Ethernet interface of the router, which is 0/0/1 IP address. We will give it one of 192.168.20.1 and a /24 subnet mask, so 255.255.255.0, and we will run a no shutdown as well. Okay. Finally, we will configure the network settings of the two PCs. Starting with the PC in VLAN 10, go to Desktop IP Configuration, and we will give it 192.168.10.10 as its IP address. The subnet mask of /24 is the one we need, and a .1 for the IP address of the gateway. Similarly, we will go into the PC of VLAN 20 and do exactly the same thing by, of course, applying the appropriate network settings. So we will assign it an IP address of 192.168.20.10, copy it, the subnet mask of /24 works just fine, and then use the .1 IP address for the default gateway. We will fast forward the time to ensure that all of our changes have taken effect, and in theory each PC should communicate with one another. So I will open up the PC of VLAN 10, run ipconfig. We see that it's got the .10.10 IP address, so if I run ping 192.168.20.10, we're getting no feedback. The first request resulted in a request timed out error, but the subsequent 3 ICMP requests succeeded. So if I run another ping against the same IP address, we get 0% loss, which is great. And let's confirm that we can do the reverse. So I am inside the PC of VLAN 20. If I run ipconfig, we can see its IPv4 address, and we should be able to ping 192.168.10.10, which is the IP address of the PC of VLAN 10. And indeed, we are capable of doing so. So this is how we can configure VLAN routing via the traditional method, which is also referred to as router on a leg method. Obviously, this method is not very popular these days, simply because, as you can imagine, it's not very scalable, and also it's more expensive because each VLAN requires its own interface on the router, and considering the fact that most organizations these days have a multitude of VLANs in their environments, this approach is not really recommended.